Namaste Dr. Karthik. My name is Yash Abhay Gujar. I am 22 years old and I am third year aerospace engineering student at Amity University, Noida. I am applying to your lab because my research interests in high-speed aerodynamics and flow control perfectly aligned with the work done at HiSIL. I am writing to you on the specific recommendation of my mentor, Professor Neeraj Kumar Galod, who identified that my current work on spike bodies will benefit immensely with the experimental expertise you have. My current CGPA is 7.85 and SGPA is 8.56. The class topper holds the CGPA of 8.3. However, I also want to highlight my performance in core subjects relevant to your lab. I have scored perfect 10-pointer in aerodynamics and propulsion. To highlight my achievements and skills, I am the first author of the paper titled Passive Flow Control of Mach 4 Mixed Compression Intake using Chevron Grooves, which has been published in FME Transactions, a Q2 index journal. In this study, I have modeled the 2D Mach 4 mixed compression intake to solve the problem of shock boundary layer interaction. In this study, I did the parametric sweep of downward, upward and mid-surface grooves configurations using RAN simulations with K-omega SST turbulence model. My study concludes that the upward chevron case achieves the best performance among all the cases. These upward grooves act as the micro ramps, which creates a strong counter-rotating vortices which re-energizes the boundary layer. I have also verified the results of this 2D study with the 3D simulations of the intake. Currently, I am working on the numerical investigation of double disc Aerospike for drag reduction in blunt bodies. For this study, I have modeled the blunt body fitted with double disc architecture. For this project, I have done both 2D axisymmetric and 3D steady RANS simulations. Here the physics is about shock manipulation. The double disc architecture breaks the strong detached bow shock into the series of oblique shocks. The changes in the shock structure result in 84% in drag reduction compared to baseline blunt bodies. I am currently working on the manuscript of this work and also extending this to Unsteady regime. I am basing the Unsteady analysis on the foundation work of Dr. D. Sahoo. For this project, I have designed the 3D configuration of double disc Aerospike and I have also strategically placed the aerodynamic holes in the second disc. Here the physics is critical. These holes helps to mass transfer from the recirculation zone to the wake, effectively stabilizing and managing the flow unsteadiness and the shear layer. This collaboration is exactly why I want to join the HiSIL lab. I have simulated the steady flow fields and also beginning to look at unsteady simulations with the help of Dr. Sahoo, but I lack the experimental experience. I want to join your lab because I want to understand the unsteady pressure transducers and Schlieren diagnostics, how they use to capture the pulsation mode and buzz we see in spike bodies. I want to bridge the gap between my CFD analysis and the real world physical simulations. I have reviewed the terms on your website. I accept the unpaid nature of this internship and also will arrange my own accommodation. I also agree to submit 6-page technical report at the end of internship. I am available for 8 weeks from 13 May to 4 July 2026. Thank you for your time, sir.